Audio Jungle. Audio Jungle. Audio Jungle. Audio Jungle.
Hi and a very good day. I'm Yashika and my fellow group members K7, Mohammad Hakil and Mohammad Amjad will be presenting about the production of activated carbon from rice husk by sodium hydroxide activation and its supercapacitor. And this is my group poster which contains abstract, introduction, methodology, results and discussion and also conclusion. That's all from us. Thank you.
Selamat sejahtera. My name is K7, son of Murali, and now I will explain the abstract part. FTIR, N2 absorption, dissorption isotope, thermogravimetric analysis, and also the scanning electron microscopy were used to characterize 4 activated carbon samples that prepared from the rice husk. The activated carbon samples were tested as electrode materials also. The specific capacitance of the as prepared activated carbon electrode was 172.3 Fg-1 by using the cyclic voltammetry at a scan rate of 5 mVs-1 and also 198.4 Fg-1 in charge or discharge mode at current density of 1000 mAg-1.
Now I'll be explaining the introduction part. A number of studies on converting rice husk to activated carbon have been reported. Rice husk is agricultural waste accounting for about 1/5 of the annual gross rice, which is 545 million metric tons of the world. As the demand using renewable resource for alternatives is rising rapidly with the decrement of renewable resources, the study is done on the potential of the rice husk is considered to be very essential and important. Before it can be used as an absorbent, a few methods have been identified to treat this rice husk. The treatment processes include the activation of the rice husk. There is no exact method has been proven to produce a high-performance absorbent from rice husk. Moreover, the porous structure, high surface area, and low-cost activated carbon has attracted considerable attention and has been widely used as catalyst carriers, absorbent to absorb metal ions and organic molecules, or as electrode materials for batteries and capacitors. The previous studies conducted show that the rice husk needs to be activated with acidic or basic solution. However, there are no studies done to compare between these two types of dilution solution on the rice husk. There are no exact explanations on how the rice husk particles form its binding with its absorbent. However, the formation of surface complexes is most likely to be related to the predominant silica content of the samples. This is where the activation process takes place. In wastewater treatment, the adsorption process is effective in the removal of organic matters at trace level. Conventional waste treatment methods like coagulation, chemical oxidation have not been successful because these methods are stable to organic matters. With the stringent regulation and economical, feasible, reusable absorbents need to be produced fast. In order to do this, the characters and behaviors of this absorbent need to be known and investigated first. So, this research is to produce activated carbon from the rice husk from the synthesis of sodium hydroxide as the activating agent by chemical activation at different temperature, and also to prepare high specific surface area activated carbon with microporous and mesoporous ranges using rice husk as the raw material. And the final one is to identify the qualitative characterization of surface structural groups of activated carbon sample by using FTIR technique. That's all from me. Thank you.
The materials that used in this research are, first of all, the rice husk was collected from Vinh Yen region that located in Vietnam. Nitrogen used to carbonize the rice husk at 400 degrees Celsius for 1 hour and 30 minutes. Moreover, the sodium hydroxide was used to impregnate the resulting samples at 120 degrees Celsius for 12 hours. Moreover, the 0.1 of hexasulfuric solution was used to ground and neutralize the activated product, and also the hot distilled water used to wash the activated product. Besides, the preparation and characterization of activated carbon is, first of all, we need to the rice husk were washed with water to remove the dirt and other contaminants before being oven dried at 110 degrees Celsius for 12 hours. Then the prepared husk were carbonized for 90 minutes at 400 degrees Celsius under the nitrogen flow of 300 milliliter per minute. Next, the sample were then impregnated with sodium hydroxide and dried at 120 degrees Celsius for 12 hours. Then the temperature was raised to the predicted mild temperature of 650 degrees Celsius to 800 degrees Celsius at a heating rate 10 degrees Celsius and maintained at the final temperature of 60 minutes to activate the obtained material. Moreover, the AC product was ground, neutralized with a 0.1 molar of hydrochloric acid solution and washed several times with hot distilled water. Is that because to maintain a constant pH which is 6.6 to 7. Wash activated carbon samples were vacuum dried for 24 hours at 120 degrees Celsius and stored in a desiccator. By the way, the FTR spectroscopy and KBR pellet method were used to identify the surface functional group of activated carbon samples. The Boyle method determined the surface acidity and basicity of the samples. Then the number of surface basic were determined by hydrochloric acid that reacted with the activated carbon samples. EDX analyzer was used to obtain the morphology of activated carbon, and also the thermogravimetric analyzer was used to perform the thermogravimetric analysis. The BJH method was used to calculate the volume of mesoporeas, and lastly the density functional theory was used to calculate the poor size distribution of activated carbon samples. For the electrode preparation and electrochemical measurements, first of all, an aluminium foil current collector and the active material was used to make the working electrodes. Solvent was then partially evaporated by heating the mixture to 60 to 80 degrees Celsius. After that, the mixed celery laminated on each side of current collector and dried for 15 hours in an oven at 120 degrees Celsius. The aluminium foil pressed at a pressure of 20 Pascal and cut to the geometric surface area of approximately 1 cm square. Electrochemical workstation was used to perform the electrochemical measurements with a 3 electrode system in 0.5 molar of potassium sulfate electrolyte. After that, the cyclic voltammetry measurements were taken with a potential window ranging of -1 to 0 voltage Vs. The last part, galvanostatic cycling with potential limitation test was performed at a constant current density of 500 to 2000 mA per gram.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hakim bin Azlan. My metric number is AA200460. Right now, I will share with you the part of the literature review in our thesis for the activated, how to produce the activated carbon by using now and the supercapacitor. First, activated carbon is well known as the material with a porous structure and a high specific surface area. It is widely used as an absorbent in water or air treatment, catalyst supporter, electrical, energy, and gas storage material. Resources base of the activated carbon is quite varied, from the crop waste to lignite and coal. So, activity carbon obtained from these resources have high ash content and low mechanical strength. Finding the alternative sources of the raw materials for the production of activated carbon is an actual problem because the inventories of this raw material are reduced over time. Using rice husk to produce activated carbon is significantly cheaper than other precursors such as synthetic polymer and brown coals. Literature. The comparison between production of activated carbon at Malaysia and Vietnam. There are some different and similarity of the production of activated carbon. The difference is the carbonized is combined at the Vietnam. The carbonized process is combined with the NaO gas flow. Because of that, the carbonized temperature process, which is 400 Celsius, through underflow of NaO, about 1 to 3 1 rice husk, 3 NaO for 90 minutes. And at Malaysia, the carbonized is and NaO is different process, which is take time for 4 hours at 400 degrees Celsius. And the sieve, there are the literature, the rice husk sieve at mesh 60, which is 0.24. The rice husk separate at the using mesh 60 sieve, which is 0.24892 mm and 1.0 mm for Vietnam. The mixture and dry at 105 degrees Celsius overnight, and Vietnam is 120 degrees Celsius at 12 hours. The Malaysia do it in 1, 2, 3 different temperature, which is 650, 750, 850 degrees Celsius, about 2 hours. Why? At Vietnam, they do the 4 temperature, which is 650, 700, 750 and 800 degrees Celsius for 60 minutes in the gas flow of nitrogen. And after that, they wash the mixture. They wash the mixture with HCl. At Malaysia, which is use 1.0 molar, and at Vietnam 0.1 molar of HCl to make sure the pH of the mixture is between 6 to 7 for Malaysia and 6 to 8 for Vietnam. Other than that, I separate the 3 sections, which is method, production, and agriculture. Method. There are two methods to produce activated carbon, which are physical activation and chemical activation. But the physical activation is more environmentally friendly than chemical activation because no chemical reagent are needed. It is believed that the temperature activation, owing to the lower temperatures, better quality, consistency, and shorter time for activating the material. Second, production of activated carbon in the world. In 2019, as much as 4.7 billion USD of activated carbon produced in the global and rising by 5.4% against previous year. In the country that consumes more the activated carbon is from China, according to World Resources Institute report. And the last is agriculture. Why we do the thesis which is in Vietnam? Because the Vietnam is the second largest exporter of rice after Thailand. The country's rice production in 2014 was 45 million tons. Vietnam is near because Vietnam is near to the equator and has a warm and humid climate through the year that make the Vietnam the paddy grow up. And other than that, the manufacturing GDP grew at an average annual of 11.2% last year. Other than that, there are two rivers at the Vietnam which is the contribute in the production of rice, which is Red River and Mekong River. That's all from me. We go to next presenter. Thank you.
Assalamualaikum and hi. My name is Muhammad Amjad bin Azlan with metric number AA200853. And now I will present about the result and discussion. FTIR method has been used to qualitatively characterize the functional surface groups of AC samples. The result reveal that all FTIR spectrum have comparable form, the majority of which are placed on the same range of wave numbers. The bands at 2924 and 1393 per cm are attributed to CH bonding stretching of aliphatic carbon or due to CH2 of CH3 deformation. The band at 2858 per cm indicates the vibration of bonding CH3O group. The CCP increased from 144 Fg by 1 and achieved the peak value of 198 F per G. When the current density rise above 500 mA G by 1000 mA G by 1. When the scan rate rise, absorption of K plus ion reduced while the surface function group's contribution increased. So the trend of particular ability does not increase at the same time as the present density increase. Due to the stability after 1000 cycles and the retention of around 99% of original specific capacity, the AC electrode is still able to charge or discharge excellently. I think that's all from me. Thank you.
As a conclusion, the three objectives that have been stated earlier is achieved. The activated carbon from rice husk was successfully synthesized at different activation temperature with sodium hydroxide as the activating agent in the range of 650 to 800 degrees Celsius. From this process, it can be said that high activation temperature, which is 800 degrees Celsius, resulted in high specific area and high mesopore contribution. This improved the gravimetric capacitance of the activated carbon when used as active material in supercapacitor. The qualitative characterization of surface functional groups were successfully determined. The total acidic groups decreased gradually with increasing activation temperature. The acidic groups of carboxylic, lactonic, and phenolic decomposed at 100 to 650 degrees Celsius, which is lower than that of basic groups of quinone and carbonyl at 650 to 980 degrees Celsius. Hence, the activated carbon has a larger amount of acidic groups at 800 degrees Celsius. It is because higher activation temperature leads to lower amount of acidic groups and larger amount of basic group. So, activated carbon obtained from rice husk by sodium hydroxide activation at 800 degrees Celsius may be a suitable candidate for the application as supercapacitor electrode material.